Hello, this is Math2270 coming to you from the College of DuPage during the summer of 2020, and the title of this lecture is, well, this is the first continuation of the Heaviside. When last I left you, you were working on this problem, and I hope you finished it, but maybe you didn't, so just in case, you know what to do. Let's see how you did. Well, remember that the function has to be of this form for us to use this table entry. And so we do have to do that shift. Also, please remember that this capital F of S is the transform of F of T, not the shifted T. Kind of a subtle point. So here was the problem that we had, and you see this first function that we have here, the F of T is going to be 2t cubed. But you see it shifted very nicely already, so that's not a problem because here's a shift of 6. And here, this function, the f of t, is going to be 7 minus e to the minus 3t. So when you shift it, you get exactly what we have. So this is kind of a nice problem in that respect, and you think about it this way. So now we can do the transform term by term. So here what we're going to do is the 10 just sits there, and it's the Laplace transform, which is going to give you this, which is e to the minus 12t over s. So that is good. We go to the next one. This is going to be the 2 just sits there. This is the transform of t cubed. We get that from this formula 3 here, and we put that in, and then this is minus, and this is the function that we have here. It's already shifted, and so we do first have the 7. That's this first formula, 7 times that, and then the next one is e to the minus 3t, and I'm going to get 1 over s minus a minus is a plus 3, and that is times e to the minus 4t. I can simplify that a little bit. All I really did was 2 times 6 is 12. And that's our first example. Here's our second example. Again, the functions have to be in this form before we can use these formulas. Okay, so you see this t squared has not been shifted by 3. And so I have to shift it by 3. But when I shift it by 3, I can't change the value because it was minus t squared. So I add and subtract the same number. And we'll deal with that in a minute. But now I've done a shift of 3. Here I'm going to have a shift of 5 on the, but I just had a cosine of t. I didn't have the shift of 5 there. So as I put it in, I have to be adding 0 in a clever way. And then I have that. So now I've set this up, and I've added the shifts in and then fixed it up so the shifts didn't make a difference except in my calculations. Now, what I'm going to do here is I'm going to expand this. This is going to be a plus b. And when you do a plus b whole squared, you get a squared plus 2ab plus b squared. So here I got the minus. I'm just leaving that on the outside for now. This is going to be t minus 3 whole squared plus 6 times the t minus 3 plus 9. And that's times this plus. And here I could perhaps use the cosine addition formula, but it turns out there's a nicer formula, which is formula 16 in your table. You'll get the same answer, but this is probably quicker. And so this is going to be 1 times, let's see, this is going to be cosine of at plus b, so b is going to be 5 and a is going to be t minus 5, and we'll do that in just a moment, and that's shifted 5. Okay, so now what we're going to do is just go through and do these calculations of the transform, and we're using this. But remember, this is shifting not f of t minus c, but this is f of t minus c, but this is the transform of f of t. So that's the transform of t squared. That's the transform of t. That's the transform of 9. And then I'm multiplying that by e to the minus 3s. I'm using this formula 27 there. I'm using the formula 16 here. The a is 1 and the t is this formula right here. It's just t. And then plus 5, so when I do the shift I get this. And cosine of 5 is a number. That's cosine of 5 radians, and sine of 5 is a number. That's sine of 5 radians. We'll just leave that this way unless we're doing an engineering application problem. So there is the answer to problem B. Let's look at problem C. Now problem C presents itself not in a Heaviside format, so we have to turn it into a Heaviside format. Notice that the t to the fourth is up here and it persists in the second thing. So I just start out with t to the fourth all the way up till when I hit 5. And when I hit 5, what I'm going to be adding, the t to the fourth was already there, is 3, the Heaviside function that makes it kick in, and then this is the sine of t over 10 minus 1/2. Now, the shift that's going to happen here is a shift of 5, and if I think about that for a while, factoring out a 1 over 10 will make that groomed nicely. And so this shift is already here. So now I'm going to take the Laplace transform of this term by term. So this one, I'm going to use the formula down here, formula 3, and get 4 factorial over s to the 5th plus the 3 just sits there, but this is u sub 5 of t times the sine of t, which means I'm going to have e to the minus 5s times a over s squared plus a squared, and a is 1 over 10, and that's going to be 1 over 100, and when I simplify, this is the answer that I get. One final example. Again, this is not given you in the form you want it, so we're going to transform this into a Heaviside function. All the action happens at 6, but notice here the t is in this part of the equation, but then it goes away. So when I formulate this, what I have to do is I have to have the t to start out with, but once the Heaviside function kicks in at 6, I have to subtract the t, and I have this. Now, I need to shift everything in this second term by 6, but this term's already shifted by 6, but this one is not. So I have to subtract 6 and add 6 at the same time. So I've groomed this now so it lines up, and I've done the shift. Now, I am going to do some arithmetic here, and I do the arithmetic, and I get minus 14 minus t minus 6 plus t minus 6 whole squared times the Heaviside function sub 6 at t. Now the function here is g of t is equal to t squared minus t minus 14. So that is what this f of s is going to be based on. So now what I'm going to do is, now this was really e to the minus 6s all over s, but I put one of the s's in here. So after I do this transform, doing that one, and I didn't show the 1 over s thing here, but that's all right. So this is 2 over s cubed, 1 over s squared, and minus 14 over s. Now we're going to do some inverse transforms. So you want to find the inverse transform of each of the following. You know what to do. Give it a go so you'll better understand what we do. When we come back in, 18